Hello everyone, today I'm going to talk about the TCP model and the OZ model. The TCP model is a practical model and the OZ model is a theoretical model. So today I'm going to explain with the OZ model because we can see all the layers. First of all, we have the application layer. The application layer is the interface between the application and the network. It uses a protocol like HTTP for browser, FTP, and the second layer we have a presentation. The presentation is about formatting data for transmission. It uses TLS, SLS. The session layer is about establishing and managing session between application. We have protocol like SSH. We have next come the transport layer. The transport layer is managing data transmission between hosts. It uses TCP protocol and UDP protocol. We are going to talk about the TCP protocol and UDP protocol at the end of the video. We have the network layer. The network layer is about routing data packets between networks. We have IP, internet protocol, we have routers. Next we have data link. Data link is about managing access to the media and data transmission. We have a network bridge, internet protocol. At the end we have the physical layer. The physical layer stands for physical characteristic of the network, cable connection. Example, you have internet, Ethernet cable or Wi-Fi network card. So now, if a machine wants to send information to another, how does it work? Maybe if this machine wants to send an information to this one, how does it work? Here will happen what we call encapsulation. Encapsulation is when a basic information acquire new informations when passing through the layers. Maybe if I want to send the message hello from this machine to this one, I will start by the application layer. But when the application layer, here at the application layer, we call this information data. When we go to the transport layer, we call the information segments or datagram. Here at the transport layer, we will choose the protocol that with the one we want to transmit the information, the TCP protocol or the UDP protocol. Here at the network layer, we call the information packets. Here at the network layer, we will assign to the information an IP address. Here at the data link, we call that information frames. At the physical, we will call the information bits. So 0, 0, and 1. So when you send the information from this machine to this one, when the information go arise to this machine, will happen what we call decapsulation. So I can show it in Wireshark. in Wireshark. Let's connect. Here we can see that when I click a packet, my information here are changing. So here this what we call domain name system. The domain name system is the application layer on the TCP model, and the user datagram protocol is the transport layer. The internet protocol version is the network layer, and the ethernet through is the data link, and the frame is for the physical layer. So I have not yet explained all the interface of Wireshark, but in the next video I will do it. So now we can go to the addressing mechanism. We use the addressing mechanism to locate a machine in a network. We have two types of addressing mechanism: the MAC addressing and IP addressing. The MAC address comes with 48 bits and with an hexadecimal format. It is an Anchor network addressing. The IP addressing, it is an inter-network addressing. So when you communicate with a machine on the internet, you use the IP address. But in the case of the MAC address, you just communicate with component of the same network. We have two types, two versions of IP address: the V4 and the V6. The V4 is a 32 bit and the V6 is a 128 bits. Now we talk about transport mechanism. Transport mechanism. We have two transport mechanisms: the TCP and the UDP. The TCP and UDP are here at the level of the transport layer. The TCP is a connection-oriented transport, and the UDP is connectionless. What does it mean? It means that when we use the TCP, the machine sending the information to the other will first of all connect to the machine, connect to machine, the machine will receive the information by the three-way handshake. Is why the TCP transport is lower, because it takes time, and the UDP is connectionless and faster. The main difference between the two mechanisms is that the TCP, the main aim of the TCP is that the TCP want to be reliable. So the main aim is the reliability, and the main aim of the UDP is the speed. It is why when we send emails, we use the TCP model transport, and when we scream or we play online games, we use the UGP model because it is faster, but the TCP model is more secure and reliable. So now we said that the TCP use the three-way handshake. What is the three-way handshake? The three-way handshake is when the client and the server communicate before establishing the connection. Here you have, when a client wants to connect to a server, the client firstly send we call it a flag, a SYN flag. It send a SYN here stand for synchronize. So the client send a SYN flag to the server, and the server respond to the client with a SYN-ACK flag, and the client respond to the server telling that yes, I have received your flag, the SYN-ACK flag. Now the server send the SYN-ACK with a challenge so that the client can solve the challenge. When the client solve the challenge, the client send the response of the answer of the challenge to the server so that the connection can be established. It is all this process that take time so that the TCP is lower than the UGP. What we can keep in mind from this video is that the TCP IP model is a practical model, and the OSI model is a theoretical model. Secondly, a MAC address is an network address because it just communicate with equipment of the same system. Otherwise, the IP address is an network because it communicate with machine of other network.